calculate the kinetic energy of a body of mass 2 kg. So we have mass m 2 kg moving with a velocity of 0.1. So velocity v is 0.1 meter per second. We need to find the kinetic energy. We know the formula of kinetic energy, half mv square. So we put the values equal to half. The mass we see 2 and the velocity is given 0.1, but it's a whole square. So half into 2, 0.1 into 0.1. So this will cancel out. Now 0.1 I'll put 1 over 10. 0.1 1 over 10. This is 1 over 100 and this is joules. And if you want to write in decimals, it will be 0.001 joule. So this is the kinetic energy. Two bodies of equal masses. So I'll write the first body is here. We write Sm, and we have a second body. And they have equal masses. So this also is mass m. Move with uniform velocities v and 3v. So the first velocity here is v and this velocity 3v. Find the ratio of their kinetic energy. You know the formula for kinetic energy, half mv square. So for the kinetic energy of the first body will be half mv square. And of the second body, kinetic energy of the second, half m. But now here we have the v is 3v. So 3v the whole square. So it is half m 9v square. Kinetic energy 2. So kinetic energy 2, I'll just rearrange it. I'll write 9 into 1 by 2 half mv square. If you notice, this portion is kinetic energy 1 here. So I can write kinetic energy 2 equal to 9 into kinetic energy 1. So, and we need to find the ratio, which means kinetic energy of the first body over kinetic energy of the second body will be 1 by 9. The ratio 1 is to 9. How much work should be done on a bicycle of mass 20 kgs? So we have mass equal to 20 kgs to increase its velocity from 2 meter per second. So this is u to 5 meter per second, that is v. So we have initial velocity which is u, 2 meter per second, and final velocity is v, 5 meter per second. If you notice here, the object from 2 meter per second, the speed increases to 5 meter per second. So work has to be done to increase its speed, and the work done will be change in kinetic energy that we have already seen earlier. Work done equal to change in kinetic energy. Now there is a change. Is energy increasing or decreasing? Here it is 2 meter per second. The v is 2, and here now it's become faster. So there is an increase in kinetic energy. So we'll do final kinetic energy minus initial kinetic energy. Now final is half mv square, final velocity, initial half mu square. We take half m common out, so this is v square minus u square. So half, we saw that the m was 20 and the v, we saw final velocity is 5, so it is 5 square minus 2 square. So we just cancel this. This will become 10. So 10, 25 minus 4, and 10 into 21, which is 210. Work is joule. So the work done to increase the speed of this object is 210 joule. By how much will the kinetic energy of a body increase if its speed is doubled? So we do case 1 where the speed is, say, v, and case 2 where the speed is 2v. The kinetic energy in this first case is half mv square, and in the second case half m. Now the v is 2v, so 2v the whole square. So we have half m 4v square. Let me arrange it. So I put 4 here and I put half mv square. But look at half mv square. It's the same as kinetic energy 1. So here I'll put kinetic energy 1. So kinetic energy 2 equal to 4 times kinetic energy 1. So the kinetic energy will increase 4 times. Although the speed is doubled, the kinetic energy becomes 4 times. If the speed of the body is halved, what will be the change in its kinetic energy? So case 1 speed v, case 2 it is halved, v by 2. The mass is the same. So here the kinetic energy 1 is half mv square. Here the kinetic energy 2 will be half m. Now the v is v by 2, the whole square. So this is half m v square over 4. So I'm going to rearrange it. I put 1 by 4 here, then I put half m v square, just rearranged. This part is the initial kinetic energy, this. So here I'll put kinetic energy 1. So kinetic energy 2 equal to 1/4 of kinetic energy 1. So what happens to the kinetic energy? The kinetic energy becomes 1/4 of original kinetic energy. So if you notice here that when the speed is halved, is made half, the kinetic energy becomes 1/4 because it is square, it is v square. A ball of mass 200 grams, so m 200 gram, falls from a height of 5 meters. So s, or you can write h, is 5 meter. What is its kinetic energy when it just reaches the ground? And the g is given 9.8 meter per second square. Let us understand the situation. So here we have the ground, and here is an object just falling. This is a falling object. So the u is 0. We need to find the v. This is our question. And the g is 9.8 meter per second square. The height or the distance is 5 meter. So we will use the equation of motion v square equal to u square plus 2as. V square, u we know is 0. Have you seen here we've taken u? Well, for a falling body, u is always 0 meter per second because the velocity keeps on increasing. So 0, 2 is a is the acceleration. Here is 9.8. It is positive acceleration because the body is falling down, and the distance height is given 5 meters. So v square equal to 2 into 5 is 10 into 9.8. So v square is 98. Now to find kinetic energy, it is half mv square. So half, we saw the mass is 200 gram, but why am I putting over 1000 to make it kilogram? Because it has to be converted into SI unit. And the v square we saw is 98. So for v square we'll put 98. And when you cancel this, here this becomes, so you get 98 over 10, 9.8 joule. Find the momentum of a body of mass 100 grams. So mass 100 gram, not SI unit, we got to change to kg. Having kinetic energy 20 joules. We need to find momentum. So we start with the formula. Kinetic energy half mv square. So here we have 20. So this is equal to half. The mass is 100 grams, but we got to convert into kgs. So divide by 1000 v square. This cancels out. So we have 20 and 2 into 20, 20 equal to v square. So v is under root 20 into 20. So v is 20 meter per second. They said we need to find momentum, and the formula for momentum is mass into velocity. Mass is 100 grams, divide by 1000 to make kgs, velocity 20. So now when you cancel, and this will be 2 kg meter per second. How fast should a man of mass 50 kgs? So we have mass 50 kgs. So that is kinetic energy is 625. Kinetic energy 625 joules. So formula for kinetic energy, half mv square. Kinetic energy is given as 625, half mass 50, velocity v square. We don't know the velocity. So we cancel this. This becomes 25. So we have 625 equal to 25 v square. V square is 625 over 25. When you reduce this, you get v square is 25. So v under root of 25. So v is 5 meter per second. So you should run with a velocity of 5 meter per second. So that will get a kinetic energy of 625 joules. A horse and a dog are running with the same speed. So this is the horse with a speed of v, and then we have a dog also with the same speed. If the weight of the horse is 10 times that of the dog, so we'll say the mass of the dog, if it is m, of the horse is 10 times, so it is 10m. Find the ratio of the kinetic energy. Kinetic energy half mv square. So kinetic energy of the horse half m. Now in this case m, I cannot write m, it's 10m, right? V square. And that of kinetic energy of the here dog half mv square, half mv square. We need to find the ratio of the kinetic energy. Means we need to find kinetic energy of horse over kinetic energy of dog. So kinetic energy of horse is half mv square over of the dog is half mv square. So half will cut off. So the ratio will be 10 over 1. So ratio is 10 is to 1. A ball of mass 0.5 kg. So we have mass m 0.5 kg slows down from a speed of 5 meter per second. So initial velocity 5 meter per second to 3 meter per second. Final velocity 3 meter per second. Calculate the change in kinetic energy. So let's first find out the initial kinetic energy. Initial kinetic energy will be half m initial velocity, that is u square. So half your m is 0.5 and your u we saw is 5 square. I'll just keep it here, I'm not going to calculate. And then we have final kinetic energy. So we have final kinetic energy half m v square. So half your m here is 0.5, final velocity is 3 square. Now to find the change in kinetic energy is final kinetic energy minus the initial kinetic energy. Final we saw was half m v square, initial half m v square. Now we can take half 0.5 common out. What will remain inside is 3 square minus 5 square. So this would be half 5 over 10, 9 minus 25. 5 over 10 and 9 minus 25, that would be minus 16. And on cancelling it, you will get 5 into minus 8 over 10. So that is minus 4 joules. However, energy is a scalar quantity, so you write change in kinetic energy is 4 joule. Two bodies having equal mass, so body 1 and body 2, equal mass, so m and m, and they move with uniform speeds of v and 2v. So velocity v, here 2v. Find the ratio of their kinetic energy. So kinetic energy 1 half mv square, and kinetic energy 2 half m 2v the square. Now we need to find the ratio. So we'll do kinetic energy 1 over kinetic energy 2, which is half mv square over half m, now v square by 4v square, because it is 2 square. If you notice here, it is half m 4v square. We cancel. So that is 1 over 4. So the ratio of kinetic energy 1 over kinetic energy is 1 is to 4. What is the kinetic energy of a body of mass 1 kg? So you have mass equal to 1 kg moving with a speed of 2 meter per second. So velocity 2 meter per second. We need to find kinetic energy. Formula half mv square, half mass 1 2 square. So half into 1 2 square 4. When you cancel, 2 joule. Two objects of equal masses. So object 1 and we have object 2. Equal masses means the masses are the same. So one mass is m, the other mass is also m. Moving with uniform velocity of 2 meter per second and 6 meter per second. So in the first case, the velocity v here is 2 meter per second, and here the velocity is here 6 meter per second. Find the ratios of the kinetic energy. So kinetic energy half mv square, which is half the m, and v is 2 square. So this will be 4m over 2, and I'll just keep it this way. And here kinetic energy 2 half mv square. This is v is 6 here, so half m 6 square. So that is 36, 6 square 36, m over 2. Now we need to find the ratio. So to find the ratio, we do kinetic energy 1, or which is 4m over 2 over kinetic energy 2, which is 36m over 2. So the m, this will cancel, the m will cancel. What is left now will be 4 over 36, that is 1 by 9. So the ratio of their kinetic energy will be 1:9. A body of 2 kgs, so mass 2 kg, falls from rest, means u equal to 0. It is beginning from rest to 0 meter per second. What will be its kinetic energy during the fall at the end of 2 seconds? So time 2 seconds. Now we have to find kinetic energy. We have to find the final velocity. To find the final velocity, we'll use the formula v equal to u plus at. Now v we need to find. The u we said it starts from rest, so u is 0. The a is given to us here 10, the acceleration due to gravity, and the time is 2. So v is 20 meter per second. So at the end of 2 seconds, its velocity or its speed equal to 20 meter per second. This is important because we need to find now kinetic energy. So kinetic energy is half mv square. Half. The mass we know is 2. V we found out here. We found out the v is 20. So this is 20 square. So we have kinetic energy half into 2 into 400. So this cancels. 400 joules is the kinetic energy at the end of 2 seconds. So kinetic at the end of 2 seconds is 400 joule. On a level road, a scooterist applies brakes to slow down from a speed of 10 meter per second. So initial velocity 10 meter per second to 5 meter per second. Final velocity 5 meter per second. If the mass of the scooterist in the scooter is 150 kilos, so mass 150, calculate the work done. Now in this case, the work done will be the change in kinetic energy. So work done equal to change in kinetic energy, which means work done is final kinetic energy minus initial kinetic energy. Now what is final kinetic energy? Half m v square, final velocity. Initial half m u square. Now I will take half m common out. So when I take half m common out, what remains here is v square minus u square. Now in the next step I'm going to substitute. So the work I saw was half m v square minus u square. So let's substitute. Half, the m is 150, v we saw was 5 square, u was 10 square. This body is slowing down. When so this will be half 150, 25 minus 100. I can cancel this. This is 75. So this will be 75 into this is minus 75. However, work done, it's got no negative sign. So you will do 75 into 75. And that is 5625 joule is the work done in slowing. And why did you get the negative? Because it was slowing down. The force here was a retarding force used. A man drops a 10 kg rock. So we have mass 10 kg from a top of a 5-meter ladder. So the height through which that rock falls is 5 meter. What is its speed just before hitting the ground? So here the body is falling to the ground. So for a falling body, u is always 0 and g is positive always because it is accelerating, increasing its velocity, it's coming faster and faster. And the v, the final velocity, we need to find. So we'll write u equal to 0 meter per second because this is an object that is coming down. U is always 0, initial velocity is always 0. So we use the formula v equal to u plus 80. Now we can't use this. Why? Because we don't know the time and we do not know the v. So these two are unknown. So we got to cancel this out. We can't use this. Maybe we'll try v square equal to u square plus 2as. V square we need to find initial velocity is 0 because the body is starting from rest. 2 a is 10 and your s height is 5. So v square here you will get 100. So v under root of 100. So v is 10 meter per second. So the velocity before it hits the ground is 10 meter per second. So we write this velocity just before hitting the ground. That's a maximum velocity before hitting the ground. The ground is 10 meter per second. Now we have to find kinetic energy. Kinetic energy half mv square. Let's put the values. Half m is 10, v we saw 10 square. So when we cancel, this will be 5 into 100, 500 joule. It hits the ground with a velocity, with a kinetic energy of 500 joule. Calculate the work done by the brakes of a car of mass 1000. So mass of the car, when its speed is reduced from 20 meters, so u, to 10 meters, v. Initial velocity 20 meter per second, final velocity 10 meter per second. Now once again, work done is change in kinetic energy. Change in kinetic energy. Change means initial, not initial, we have to put final first. Final kinetic energy minus initial kinetic energy. Now final will be half m final velocity minus half m initial velocity. Now half m I can take common out. What remains inside is v square minus u square. Now let me put the values. Equal to half. The mass is 100, 1000 not 100. V square is 10, so 10 square, u square 20 square. So I do it right here only. So half into 1000. 10 square is 100, 20 square 400. So this cancels here and I get 1000 divided by 2 is 500. 100 minus 400 is minus 300. Here I am finding the work done. So work done is 151234 and joules. I didn't put the negative sign. Now what does a negative sign indicate? That for this work done there was a force used, because we know work equal to force into displacement. This force, the direction of this force is opposite to the direction of the motion because of the car, because here we are stopping the car. The car moves forward, but if you want to stop the car, if the car is moving forward, if you want to stop the car, you've got to give it a backward force. That is why the W comes negative, to show that the force involved in this work is a retarding force.